Welcome to Data Engineers Lunch number 109. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Our topic for today is building a data lakehouse on your laptop, and it will be presented by by Alex Merced from Dremio. He'll discuss this building a data lakehouse work on your laptop. This immersive session aims not just to educate, but to empower attendees with the knowledge and tools needed to experiment with and implement their data lakehouse solutions. By the end of this workshop, you should be able to have a functional data lakehouse environment on your laptop, enabling you to further explore and apply what you've learned into real-world scenarios. Ooh, excuse me. I have the wrong link pulled up. The co-organizers for this event are Rahul and myself. If you are interested in speaking, please reach out to me at my email or at marketing@anant.us. Thank you to everyone at Data Community DC for their support. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Thank you to all of our organizational sponsors. If you have a question, please ask it. We expect respect to be given to all, so please ask it politely. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. Thank you again to all of our sponsors. And with our shortened intro today, I'm going to pass this to Alex. Thank you, and really looking forward to this talk.
Awesome. Hey, everybody. My name is Alex Merced. I'm a developer advocate, now senior tech evangelist here at Dremio. And today we're going to be talking about building a lakehouse on your laptop. This is a workshop that I just love doing. You know, it helps people kind of get hands-on with actually seeing like what makes a data lakehouse so awesome. But before we actually get into the hands-on aspect of the exercise, I just want to make sure we lay out that we all understand like what is a data lakehouse and why does it matter and why am I using the tools that I'm using. Okay, well, before I do that, if anyone wants to download the slides for this particular presentation, this is the QR code that will get you access to those slides, along with the mini slide decks for many presentations I've delivered. It's just one big folder with PDFs of all my presentations. Also, this purple QR code over here on the left, that is the link to today's exercise. So like the blog where I go through all the steps that I'll be doing today, that's that blog in case you want to do it again later on. I will share these QR codes again at the end. And then on the right, there's a QR code for getting started with Dremio. Okay, again, I'm a senior tech evangelist here at Dremio. I've worked as a web developer. I've worked on the data side of things. I am one of the co-authors of Apache Iceberg Definitive Guide. I host several podcasts, which you can see here. So these are all podcasts you can subscribe to on iTunes, Spotify, and you can find all those links to everything over there at this URL right here to be able to kind of hear more of what I have to say about the data space, constantly talking about Dremio, the data lakehouse, Apache Iceberg, Apache Arrow, Project Nessie, and so many other things. So again, if you find that stuff interesting, do check out these podcasts. But with that, let's kind of talk about what is a data lakehouse. And to understand why a data lakehouse, we need to understand sort of like where we came from. Okay, so traditionally we had siloed systems like databases and data warehouses that would abstract away a lot of things. They would abstract away how the data is stored, how we track the individual chunks of that data into individual tables. How do we track how many tables exist, our catalog? And then how do we actually parse the query, plan an execution plan, and then actually execute that plan in order to satisfy the questions that we ask of that data? All of that stuff would be abstracted in the software that is something like a Postgres or MySQL or a Snowflake or a Teradata. It would all just kind of be built in, and you didn't have to think about these things, which is very convenient and very easy. The problem is, if you wanted to use different features of different platforms, you'd have to move your data to each platform, causing chains of data movement and having to worry about trying to keep the data in sync and all these sort of logistical issues that made data move slower to get it delivered where you need it delivered, and also created regulatory headaches and escalating costs. So whether we're talking about row-based data in databases or columnar data in data warehouses. So the idea was like, how can we create a new architecture that gives us the benefits of things like data warehouses, but in a more open and flexible manner. And this is where the data lakehouse comes in. We already had something for storing the data. Okay, and that's a data lake. Okay, in the data lake, we would have our storage layer, which would be like a Hadoop cluster or object storage, like S3 or ADLS, Azure Data Lake Storage. But we would then interact directly with that data using querying tools like Dremio or AWS Athena, and we would query the data right there on that storage layer. And this worked really well. We could do some ad hoc analytics this way, but it didn't necessarily replace the data lakehouse or the data warehouse because it didn't have those other layers that enable things like asset transactions and a more wider array of possible workloads to be able to do less with the data warehouse so that way we have to move the data less often. But with the advent of recent technologies, okay, we took that storage layer, we took the computing layer, and we added the missing layers with a table format like Apache Iceberg that provides the metadata to enable things like time travel and asset transactions and other feats, schema evolution, things that weren't possible just directly on your data lake storage. And then catalogs like Nessie that allow us to track those tables and make them portable from tool to tool. Okay, and basically with this, now you actually had data sets in which you could do all your data lake, data warehouse type workloads, but you're doing them directly with the data on your data lake in a way that's flexible and open, using tools like Dremio and AWS Athena to then process that data. Okay, and a variety of tools because it's a huge ecosystem. Okay, so that's essentially what the data lakehouse does. It gives us this now flexibility where we're not to move the data as much, which means it's going to reduce, not just reduce our costs. I mean, that's a nice side effect, but more importantly, it allows us to get the data where it needs to get to faster because there's less steps to deliver to our BI dashboards, to our AI ML models, because we're getting it to that consumer level quicker. Okay, but at the end of the day, like up till now, this has been a very manual process. You have to kind of implement each of these layers and you have to maintain these layers. So it was a lot more work than just getting a data warehouse, which kind of had all that stuff abstracted away. This is why it's important to have a really solid like data lakehouse platform. So one of the tools that we'll be using today will be a data lakehouse platform. And so basically we'll use Apache Iceberg as our table format. We're going to use Nessie as our catalog that tracks all of our tables. And we'll be using Dremio as our query engine that queries those tables. And then Minio as our storage layer that stores the actual data files. So you'll see how we implement all that in a moment. But again, just to show you sort of like the role that Dremio has, not just as a query engine to query the data, but also as a full-on data lakehouse platform. Let's kind of ask ourselves, like, sort of what should a data lakehouse platform look like? Okay, a good data lakehouse platform should be able to connect to your data lake, so connect to your storage, but not just be able to connect to your object storage, but it should provide you a full suite of unified analytics so that way you can connect to your other data sources like relational databases, NoSQL databases, data warehouses like Snowflake, because you have data everywhere. And now with these different data marketplaces, whether it's a Snowflake data marketplace or the AWS data marketplace, you want to be able to unify that data where you get it everywhere instead of moving it from system to system. Okay, should have a powerful SQL query engine that allows you to federate queries across all those different data sources with powerful acceleration features that can accelerate that data wherever it is. And it should have lakehouse management features that makes it where you don't have to do as much manual maintenance of your data lakehouse, where basically your tables are kind of automatically compacted. It does automatic garbage cleanup. That way, your data lakehouse really feels like a data warehouse where it just kind of works. Okay, when it comes to having all these features in place, you should be able to access this unified access layer via the interfaces you're used to: ODBC, JDBC, REST, Apache Aeroflight. So that way you can feed that data from wherever it is into data science notebooks, dashboards, data applications. And a platform that kind of offers you all of this is Dremio, okay, which can be self-managed. The version we'll use today is the self-managed, self-deployable version, but there's also a cloud-managed version that coalesces all these features. Again, the exercise we're about to do now is this QR code here on the left. So again, if you want to have that open while you do it, if not, you can just follow along with me. And then again, I've created other exercises that are a little bit more wider, if you like today's exercise, where you can actually go from end to end. So you'll go from a data source like a Postgres or a SQL Server or a MongoDB, take that data and move it all the way to a dashboard using Apache Superset, using sort of Dremio as that intermediary layer. Okay, and these tutorials will walk you kind of through that sort of so you can see what the end-to-end data lakehouse lifestyle is like. Okay, and all of these can be found at the Dremio.com blog, but here are the QR codes. I've actually put out some new blogs on this last week. So now there's going to be, I just put out a Kafka one about ingesting Kafka data into the Lakehouse. There's one also on MySQL and Elasticsearch that just came out. And this week I'll be publishing one on Apache Druid. So lots of blogs where you can kind of get hands-on and do this all from the safety of your laptop. So you can actually see what it's like to do data engineering on the data lakehouse in a small sort of learnable environment. Okay, so now that we've established all that, let's get on with the exercise. So I'm gonna head over to the blog. This is gonna have all the details for our exercise. We're using Docker, so you do need to have Docker installed to follow this up. Also, generally my advice when you're doing these blogs, like you should be able to do this one just fine, but a lot of the other ones do have a few more containers running. Okay, and again, for those who are new to Docker, essentially Docker is a way for us to sort of spin little mini virtual computers, referred to as containers, and those containers can then work together to kind of create an environment that normally we would have to like deploy a bunch of VMs in AWS for, and it would be complex and costly to do. We can just kind of spin up a sort of a mock version of that in our local environment to get hands-on. There's a lot of other uses for Docker, but that's how we're using it today. But again, for some of those other tutorials, you may want to have like 6 gigs or more of RAM available for Docker to be able to handle those containers. So if you ever get like a 137 error, it's because there's just not enough memory allocated to Docker, just as a heads up. But again, we're using different pieces. We're using Dremio as our data lakehouse platform. So that's what we're using to query our data lake. Nessie is going to be our catalog. That's what tracks the individual tables. And then Apache Iceberg is the table format. And then we're going to use Minio as our storage layer, our data lake. Okay. And essentially all you have to do is copy this right from the blog. This is the Docker compose settings. So essentially this details what containers we need, whatever our environment looks like. So it's already all prepared for you. Okay. I would just head over to my favorite editor. So I'm using Visual Studio Code, could be anything. But I'm just going to create a file called docker compose.yaml. Okay, I'm going to just copy over this stuff. Okay, so there's all the details. And now in order to spin up this environment, it's literally just one command. I just go docker compose up. And what this does, it tells Docker to read the Docker compose file in this folder. Okay, and says, okay, generate a bunch of containers based on the description. And it's generating 4 containers. This Nessie container, which is going to be our catalog, this Minio container, which is going to be used for our storage, this Dremio container, okay, which is being used for our data lakehouse. Okay, and then again, Iceberg is just the way the data, I'll show you where Iceberg kind of comes into play. So we just hit Docker compose up, and now Docker is spinning up all those containers. Okay. And we'll give it a moment. It's running. Okay. And again, it might take a moment for you because these are going to be the first time you run this. So it has to download all the images from Docker Hub to run this. So it might take a few minutes for it to all sort of generate. Okay. What I'm going to do actually is I'm going to redo that just because I don't need the notebook service. So I'm going to just do Docker compose up. I just need Dremio, Minio, and Nessie right now. And just so you see what I'm doing, when I say Docker compose up, if I just do Docker compose up, it does each service. But really, I just want Dremio, I want Minio, and I want Nessie, so I can refer to them by name and just say, hey, just give me those. Okay, so that's what I'm gonna do here. Okay, so now it's spinning up those containers. Okay, and downloading those particular images. Okay, and that'll be started up in a few minutes. Okay, so again, if you're following along with me, give it a few minutes for it to just kind of create all those containers and download those images. Okay. And as you'll see here, there is an extra service called Notebook. That's a separate thing that I have in the setup that allows you to kind of, gives you like a Spark notebook environment where you could do some PySpark against a Spark 3.3 image. But we'll come back to that. Okay, so that's all generating there. That'll take a moment, but let me go back to the blog for a moment. Okay, but essentially what's going to happen is that once we're done, we're going to have our Nessie server, which kind of runs in the background, tracking our tables, and that's going to be available to us to communicate on port 19120. Don't worry about what the port number is really. It's just gonna all kind of work. Okay. Then we're gonna have Minio again that act as our storage layer, and then Dremio that act as our query engine. Okay. But once it's all set it up, we're gonna go create the places where we want to store data on Minio, which are, if you ever use S3, those sort of top level storage layers are called buckets. Okay. So think of a bucket as a top level folder where we can store data. Okay. And so we're gonna need to create some buckets to store data in. So let me just see how that's doing. Okay. Looks like it's going. And I think the other two should have started. Okay, so that looks like it's running. So I'm gonna head over to localhost. Okay, and again, localhost just refers to your computer. These containers are running on my computer, and I've mapped them to certain port numbers. So I've mapped the Minio to port 9001. Okay, so if I head over to localhost 9001, that's gonna take me over to the Minio dashboard. And the username and password is admin and password. Now, where did I set that username and password? Where did that come from? Well, if you take a look at the Docker Compose settings, if I go to the Minio section, you'll see here there's environmental variables that I specified that specify that username and password in case you wanted to change it if you try this again later. Okay, so I do admin and password. I log in. Here I am inside Minio, and what I want to do is create a bucket. So I'm going to click here on create a bucket, and I'm going to create a bucket called warehouse. Okay, it doesn't really matter what you call it, but for this exercise, I'm calling it warehouse. It's where we're going to warehouse our data. Okay, so I create the bucket, and that's really all I need to do here for now. Okay, so now I have the bucket on where I can store data. Okay, now I can head over to localhost 9047 because that's where Dremio is going to be hanging out. So I go over here to localhost 9047. And basically, since it's the first time I'm going to Dremio, it's going to want me to set up an initial user, set up my admin account. So I set up my admin account. So, put in all the information. Okay, and once that's all set, you're now logged into Dremio. Okay, and then this is the Dremio UI. Okay, and the idea here is this: it's supposed to provide you a nice intuitive UI, kind of like logging into Snowflake, but instead of having to store your data separately, you're really just working with your data where it already exists. So the way Dremio works is that you just say, hey, tell me where the data is. Okay, you don't have to copy the data into Dremio. Dremio goes to where your data is. So I can add a data source, and there's several different sources I can add. Okay, so you can add databases like MongoDB, MySQL, Oracle, Postgres. You can connect it to your Snowflake account. Actually, I did release a blog on that last week, showing you how you could use some of Dremio's features to help you reduce your Snowflake costs. Okay, but for our purposes, we're going to connect to Nessie because again, we have that Nessie server running, and that's going to be the way we figure out, hey, where are our tables? So Nessie is going to track those tables, and then other tools like Spark, Flink, they can also communicate with that Nessie catalog, so that becomes the arbiter of our tables, and that's the way every tool knows which tables we have. So those tables become portable. Okay, so I'm going to name the source Nessie. The API URL is going to be this. Okay, and again, this is all in the blog, but it's basically Nessie 19.120 API version 2. Okay, it's the second version of the API. Since we're just running this as a container, there is no authentication, so you can just put none there. In production, you would want to set up authentication. Okay, and then this gives the information that Dremio needs to talk to the catalog. But what the catalog does is that when a Dremio or any tool says, hey, Nessie, I'm looking for table A, it doesn't actually give you the table. What it does, it gives you an address of where the table's information is located. Because all the information about the table, when it comes to Apache Iceberg, is stored in metadata, which is stored right there on the data lake with the data. So basically what Nessie's saying is saying, hey, here's where you can find those metadata files. So that way you can begin understanding and reading the table. But Dremio needs to have access to that storage. So I have to go over here and give the details for the storage that Nessie is going to be pointing me to, which is going to be our Minio bucket. So for all intents and purposes, Dremio thinks it's talking to S3, but it's going to talk to our Minio, and we'll configure it that way. So over here, I'm going to say, hey, I want you to talk to the warehouse bucket. That's going to be where all the data gets stored. And basically, since I'm not using AWS, I'm using Minio, the access key and secret are essentially my username and password. So admin password. And then I just have to
Alex, if I could step in for a second, I would add that if you're going to use this for absolutely anything, you should definitely add a bunch of random characters to the end of your AWS root path. I read a really interesting article this week about how you get charged for any attempted ingress into your AWS bucket. So if you're just putting warehouse and somebody else has warehouse, there might be some cross streams that
if you're actually using AWS, yeah. So
correct,
if you're using AWS, ADLS, yes, you get charged for everything. So there's a potential risk if you have a bucket that's the same name that somebody else is using, and the requests are hitting your bucket. So yeah, that was a really interesting article. I did find that article really amusing, because I think they ran like a $1 million bill because of that.
And
so so you want to have unique names is, I guess, the big advice. Always have your buckets have unique names. But since this is using Minio on our local machine, you shouldn't have that risk.
Okay, thank you. Yep.
Okay, but again, password, just make sure I typed in password correctly. Now again, since this is Minio running on our computer, not in the cloud, basically there is no SSL, it's not a secure internet connection. So I can check off the encrypt connection because there's no SSL certificate on my computer. So that's going to get checked off for when you're doing this exercise. Again, theoretically in production, you would, if you're using AWS, you would want to encrypt the connection. If you were deploying your own separate Minio server behind a security certificate, you would want to encrypt the connection. But for this sort of developer exercise here, we don't want that checked off. Now, there's a few connection properties that we're going to set to tell Dremio that, hey, we're not using AWS S3. We're actually using a S3 compatible storage layer, in this case, Minio. Okay, and the way we do that is a couple settings. The first one is this one, FS3 path style access. So what does this mean? Okay, because this was something that confused me for a while, and then now that I know what it means, it's pretty clear why this is important. Okay. So generally what happens when you're using AWS S3, oftentimes you don't see the API calls that are going to S3 behind the scenes. So if you're accessing bucket A, usually what's happening is you're seeing something like, bucket A dot AWS something.com. Okay. So basically bucket is actually part of the URL. It's a subdomain of the URL. So that's typically how requests are being sent to S3. But for Minio and a lot of other S3 compatible storages, they don't do it that way. They use the bucket is in the path of the URL. So in this case, really, it's going to be like Minio 9000/warehouse. So you see, this is the path of the URL. So basically, this tells Dremio that, hey, and this is the same thing for any tool you'll use where you might use Minio. You have to kind of set this setting, telling that tool to not put the name of the bucket as a subdomain, but put it as part of the path of the URL. So that way it sends it makes a request to the right URL. So this has to be true. So that's all that's doing. It's just telling Dremio, hey, when you send requests, send it this way. Then you have to tell it where to send requests. So this setting right here. And again, all of this is in the blog. fs.s3a.endpoint is saying, hey, your S3 request should be sent to this URL. So in this case, it would be Minio 9000. Okay, and I just want to make 100% sure. How would I know if it's the right name? I check the Docker Compose. So I see here, yes, the container is named Minio. That's the right name. So that's why I'm going to use Minio 9000. And then the last setting is this Dremio.s3 compat. This means to run Dremio in compatibility mode. So basically what it's doing is using S3 compatible storage, not S3 itself. So that way Dremio knows. And that gets set to true. And as long as that's all set, we're good to go. I hit save. And there we go. I'm all set up. Okay, so now essentially my data lakehouse is up and running. Okay, I have no data in it yet, but theoretically I can now start creating and deleting and updating Iceberg tables, just like I would in any data warehouse. I can just start running full on SQL. So as an example, if I click right over here, so just to give you a tour of Dremio's UI, essentially here I have all my data sources. And again, you have lots of different data sources you can connect to. Okay. Here you have a area where you can kind of organize your data into spaces. Think of them as just folders for organizing views of the data. But here I have an SQL runner where I can start running SQL against my lakehouse, against all the sources that I've connected to Dremio. Okay. And the cool thing is you can have Dremio just running on your computer. Like I sometimes have Dremio running locally, connected to my S3 storage, so that way I can just run some quick queries against my S3 storage personally. Okay. So the cool thing is that the Lakehouse doesn't have to be a big multi-cluster environment. Dremio gives you a really great way to just have like literally a Lakehouse running on your laptop, where you're accessing your data lake directly with your local compute. But in this case, let's create a table. So if I say create table, so we'll just create something simple. I'll say, hey, in our Nessie catalog, I want to create a table called names. Then I put the schema in there, just standard SQL. We'll have one field called name. That's a varchar. And the cool thing is I can actually run multiple queries at the same time. So what I can do is I put a semicolon there, and I can say, hey, after you do that, insert into Nessie.names values Alex, my brother Tony. Okay. And then I can hit run. And it's actually going to run those queries. It's actually creating a table. Oh, did I do something wrong with my insert? Let's see here. Insert into Nessie.names. What did it say? Hey, the number of fields and values. Oh, oops, these should be separate parentheses. See? And the good thing is that the errors are pretty clear. So basically, when you make a mistake, so like this was a me mistake, you can kind of fix it pretty quickly. So now if I run that again, I'm just going to comment out that first query since I already created the table. Okay, and it's going to run that insert. Okay, and ta-da. Okay, the query should have been ran. Cool, and there we go. So we see that two records were inserted. Okay, now the cool thing is this was not like, again, Dremio doesn't have its own storage. This is happening on your data lake, basically. So if I go back to Minio, okay, and I go back to here, the object browser. See, I see here in the warehouse, there's now files in here. Okay, so this would be like your AWS S3, your ADLS, whatever you want to use as your data lake. And there I can see the names table. Okay, so here's the actual physical metadata. And you'll see like there's these folders. So these folders here have the data. So this is where Iceberg stores the data. Okay, so you'll see here Parquet files that actually have the different data in there. And then here in the metadata folder, you'll find the actual metadata. So you see like these metadata.json files. That's the metadata file that Nessie tracks. So basically, you'll notice like there's 3 of them. So you see like here's like 0, 1, 2. So this is like the newest metadata. Like this is like the last change we made to the table. So basically, when we first created the table, Nessie was tracking this URL, like basically saying, hey, this is the file. But when we updated the table, then was this, and we did another update, it switched it to that. So every time the table gets updated, basically a new one of these metadata.json files gets created, and then Nessie swaps the reference. So it's saying, hey, now the names tables points to this metadata. So that's how Dremio is always able to scan the right version of the table, the latest version of the table. Because every time it goes to Nessie, Nessie's always pointing to the latest metadata.json. And if I were to go open up that same catalog in Spark, it's always going to then read a consistent version of the table, because it's the catalog that makes sure that you're always being directed to the right metadata file. Okay, and that's generally how Iceberg tables work. Okay, and you can see all that there, which is pretty neat. Okay, cool. Now, another cool thing you can do specifically with Nessie catalogs, this is what makes Nessie catalogs particularly special, because there's lots of things you can use as Iceberg catalogs. You can use Hive catalogs. You can use other third-party catalogs. You could just use a file storage. Okay, so for example, if I were to connect Minio as a data lake storage instead of connecting it through the catalog, so I can go over here, add a source. Instead of adding a Nessie source, I could add an S3 source, and we'll call this Minio. Okay, and again, I would put in the same information: username, admin, password. I don't encrypt the connection. Okay, don't need to add buckets. I turn on compatibility mode. We say, hey, the warehouse bucket is what we want to have access to. And then I add those connection properties. Style access true. And again, I've just done this so many times that I have it memorized. It's all documented in the docs and documented in the blog post. So don't think you have to memorize this. Again, and then the endpoint. And the endpoint is going to be Minio 9000. Okay, and see now I have that Minio cluster not connected as an Iceberg catalog, but as object storage, and I can actually browse those files. So I can actually now see all those files in my object storage from Dremio, and I could actually query one of those. Like if I just wanted to query the Parquet file directly, I could. So I can go over here and see, you just see it has 2 records inside of it. Okay, but I could also write Iceberg tables directly to my object storage. Okay, generally you don't want to do that for production purposes. Like it's fine for like offhand tables. The reason being is that I'll show you. Actually, let's just write the table and I'll show you. So if I were to create a table inside my object storage Minio, I would do something like this. Like, hey, Minio dot create table Minio dot people. Okay, create table Minio dot people. And then we'll say person varchar. Okay, then I will insert into Minio.people values. Say Alex%. Okay, and now I'm writing the table directly to my object storage. I can do this. I can do whatever I want. Okay, that's a great thing about this. Like I'm actually working across multiple sources. And again, I could also connect my MySQL, my Postgres, my Snowflake, and do joins, create all sorts of queries across all those data sets working together. But now if I sit here and I create a table. Now, if I go back to Minio, okay, I should see that there's more. Now there's the people table. So I can see the people table. But now when I open the people table and I go inside the metadata folder, you'll notice something that wasn't in the other folder. Notice that there's this file called version hint.txt. Okay, this is what makes writing to object storage directly different than using a catalog like Nessie or Hive. Because generally when you're using like Hive or Nessie, the way tools like Dremio and Spark know which version of the table to query is because the catalog says, go look at this particular metadata file. When you have an object storage or a storage version of an Iceberg table, since there is no catalog, what it does, it uses this file here called version hint.txt. And that inside that file is the actual file name. Like, hey, here's the right metadata file. So in this case, it would point to v2.metadata.json. The thing is that that file gets updated. So every time you update that table, that version hint.txt and certain object storage providers don't have the same guarantees when you update a file on that object storage that you can run into issues when multiple writers are trying to update that file. So it's not an issue about the engine. It's just an issue with how the object storage sometimes, what guarantees it has on the right side when it comes to updating that file. So you could have 2 people update the table at the same time and create an issue. That won't happen with like a Nessie or a Hive because they have other locking mechanisms to prevent that. So just keep that in mind when if you're ever doing an Iceberg Lakehouse and you're thinking, okay, how should we handle our catalog story? Okay. But again, Dremio gives you lots of options. Again, basically you can use any storage layer as your Iceberg catalog. You can connect to Hive. Like for example, here, you can use Hive as your Iceberg catalog. You can use AWS Glue as your Iceberg catalog. Okay, soon we'll be adding REST catalog support, which will open up a whole new world of catalogs that you can use. But Nessie is extra special. What makes Nessie extra special? The fact that you can do Git-like operations. So notice that when I have the Nessie source over here, you see this little like button here called main. That's because you can actually change which branches. You can actually have multiple branches in a Nessie catalog. So why is this useful? Well, let's pretend I want to update that names table. Okay, so just to do a quick, so we see where we started at. Select star from nessie.names. Oops, forgot the word from. Okay, if I run this query, I put an extra S here. Okay. Okay. There we go. Okay, so you see here, I have the data. Okay, because again, I inserted it twice. So I have the data there, but what if I want to add new data, but I don't want to immediately make that data available to production? Okay, so here's what I can do. I can create a branch. So create branch, we'll call it ingest. You can call it whatever you want in my Nessie catalog. Okay, So now if I create that branch, I hit run. Okay, the branch is now created. And now if I click over here, I can see that we have now 2 branches. So you see there's a main branch and now this ingest branch. And the cool thing is I can even scan that table or scan the catalog at different points in time using the commits on that catalog. So again, it's a very Git-like structure. So now what I can do is I can say, hey, I want to do some queries. I want to say, hey, use branch ingest in Nessie. That just makes sure that the query is running that branch. I could also use this context switcher over here. So I can say, hey, the context is Nessie on the ingest branch. And then hit select. And that would have the same effect. So either way would work. Again, a lot of nice quality of life aspects. But I can do that. And then I can do insert into Nessie.names values. In this case, we'll have read. We'll have, again, different parentheses. We'll have Tomer. Okay, we're going to insert some new people. But again, this is happening on the branch. Okay. And just to confirm that that's the case, I'll add a couple other queries. Select star from Nessie.names at branch main. And then we'll just have that same exact query at branch ingest. Okay, Nessie.names. I keep missing my typos. Oops. Keep doing Nessies. Okay, I will comment those out so we don't run those again. Yeah. Let's comment it out. Just remove that for a second. Run the query. Okay, so now that I've ran the query, if I take a look at the first one, so again, that's the branch at main. See, we still just see our 4 records. So you see nothing got added. But if I go to query 2, which is on the ingest branch, okay, show me the results. Okay. And you can see here, when I take a look at the query from the ingest branch, the 2 new records are there. Okay, notice that as I look at each query result, it highlights the query that it's showing me to make it easier for me to know I'm looking at the right tab. Okay, another nice thing about the SQL editor is I can actually have multiple tabs open to work on multiple queries. So not only can I run multiple queries in the same tab and look at those results individually separated out, but I could actually be running on multiple queries for different purposes, which is all very convenient. Okay, and again, you don't have to work on your SQL from the Dremio UI. Dremio is an SQL first platform. So you also have the ability to send SQL via REST API. You can send SQL over JDBC, ODBC, and you can send SQL via Apache Aeroflight. So all of those can be orchestrated. So you can use something like an Airflow. Actually, over the next few weeks, I should be coming out with some blogs on how to use Airflow to orchestrate Dremio. But again, basically all of that can be communicated to through code external to Dremio. So that way, anything you see me do inside of Dremio, even the administrative tasks, can be automated via SQL, allowing you to orchestrate and automate a lot of these activities. So while branching is nice, it's even cooler when you can automate it. Now, what if I want to publish those changes? So theoretically, I would keep that data on my branch. I would like run dedupes, null checks, things like that, until I know that it's been validated, and then I would want to publish it. Well, to publish it, it's pretty simple. I would just say merge branch ingest into main in Nessie. So in my Nessie catalog, take the ingest branch and merge it into main. I would just run this query. That's done. So now if I were to select star from Nessie.names at branch main, just to make sure that I'm creating the main branch. And you can see, look, now the 2 additional records have been added. Okay, so awesome. Okay, so the point is, this allows you to create some patterns to help manage code quality, because you can isolate those changes. And not only isolate those changes, if something goes wrong and you still publish bad data, you can roll back because you have all those commits. So again, if I take over here, look at Nessie, I can see that there's all these commits from all the times I changed that table. Okay, and these commits are at the catalog level. Okay, so I could roll back at the table level because Iceberg tables have their own individual commit history. But I could also roll back my entire catalog of tables because Nessie creates a catalog level history, which is pretty nice. And again, very unique to Nessie catalogs. Okay. Now our Dremio cloud actually has an integrated catalog that is built with Nessie. So you do get those features integrated into the platform when you're using Dremio cloud. Okay. But notice again, just to kind of summarize, I'm able to query the data now in my data lake, either through an Iceberg catalog like Nessie or directly on the object storage using Dremio. And I can again, also start, adding all these other data sources to basically bring my data all together in one place where I can govern it using like row, column, row-based access controls to limit that. But also I can document the data. Okay, so you see here, there's like a wiki. Okay, and this wiki can be edited throughout. So I can sit there and say, okay, hey, I may want to start organizing my data into data products and say, hey, you know what? I'm going to have so I'll create a marketing space for my marketing data product. I'm going to create a accounting space for my accounting data product. Okay, and then maybe in my marketing folder, I may decide I want to break it down to a 3-layer cake. So you've seen like, bronze, silver, gold, raw, whatever. I'm going to say raw. Okay, curated. And, oh, I created a raw space. My bad. Okay, raw. And a production space. Okay, so the idea being, and again, it's just basically, the 3-layer deal. So you have the raw data that's sort of unchanged. Then generally you have like this middle curated layer where you're doing sort of non-business logic type stuff, transformations where, you're removing nulls, you're deduping, stuff that's more cleanup data, unified data. And then you generally have that last layer where that's where you incorporate your business logic. So you're doing changes, but they're not changes to clean the data. They're changes to apply to the way your business understands the data. And then that'd be sort of your production layer that people would access, or your gold layer, or however that terminology that's evolved over like 20, 30 years, because it's not a new thing, have done. Okay. So it's, again, basically raw data, clean it up, business logic. Cool. Now let's see here. Okay. But I could take my data. So let's pretend like this is a much bigger table. And actually the cool thing about when you're working with Dremio, if you want to practice, if you click here to add source, there is a sample source. So this is just like a sample object storage with a bunch of sample data sets you can use. So if I go in here, like there's like a weather data set. Okay, and I would work with the weather data set. The NYC taxi trips data set is pretty large, and sometimes maybe a little too large for like your laptop. Okay, so while Dremio works pretty powerful, your laptop is only so powerful. But you should still be able to run a query on it. I've done it. It just takes like, it's not like a 2-second thing. It's like a 2-minute thing. But if you have like a production Dremio cluster, that's basically with production compute all nice and configured, it actually runs that query pretty fast and faster than pretty much most other tools, using a lot less compute than equivalent tools using the equivalent compute. For that, I would actually refer to our latest white paper, where we talk about how we are able to optimize costs for Snowflake users, because we're able to run the same queries with a lot less compute, allowing a lot of offload of certain queries to help reduce costs. So there's a white paper right there on Dremio.com, pretty easy to find. And then I've written a few articles on Snowflake the last few weeks that have links directly to that white paper. But cool.
Hey, Alex,
yep.
We've got a question in the chat, and it's something that I was also wondering about. Your examples so far have largely included relational databases, right? Obviously, lakehouses are intended for a lot more than just that type of data. Can you speak a little bit to accessing other types of data? For me, I'm interested in like data objects, that sort of thing.
Yeah, I would say Dremio is more built to handle the structured part of your data lakehouse. So again, using Dremio isn't your entire data lakehouse. You'll have other tools to work with different types of data on your data lakehouse. The beauty of the data lakehouse is that you have your data in one place. So you might have other tools that are more specifically designed to work with certain types of unstructured data. Dremio does work with semi-structured data like JSON files, Mongo databases. In the future, you'll probably start seeing tools that allow, like at least from the Dremio angle, I could imagine a future where people start using LLMs to take unstructured data and turn it into structured form. Some of that already happens. So that would be one way where Dremio gets involved, but Dremio is definitely more from the structured, allowing you to work with your structured data on your data lake in a more holistic way, in a lower cost way, in an easier way. Now, as far as what future features it might have for things like audio, images, log files, emails, we'll see. But right now, I would say where Dremio fits in that picture, your data lakehouse picture, it's going to be more with the structured data. Any data lakehouse is going to be comprised of several tools for different use cases, and that's part of the appeal of a data lakehouse, that you don't need one tool that does everything. But when it comes to working with your structured data, Dremio really makes the story a lot easier, and gives you a lot of it gives you great performance, but also gives you a lot of quality of life features when it comes to working with that data.
Thank you.
No problem. But yeah, so you have like data here. So for example, here's a CSV file on object storage. So I could work with CSV and JSON files. So I can just go over here and say, hey, I want to take this CSV file and turn it into a data set. Okay, so I just set my settings up so I can read the CSV file right. And the cool thing is that basically to scan this data faster, actually Dremio is collecting metadata in order to be able to scan that CSV file faster. Although ideally I could just go turn that into I can just easily turn that CSV file into an Iceberg table now, which I could just do that by saying, hey, create table Nessie.weather as select star from, and then I can just click over here. So you see all my data sets are listed over here. So see there's that weather data set, and I can just hit this plus button and that injects it there. So I don't have to type out that whole thing. Okay. And I can just run this query. And now that CSV file is going to be a Iceberg table. Okay, so that's been run. So now if I go over here, I should look inside Nessie and see there's the weather table. And if I run it, and that's going to generally scan a lot faster than just the raw CSV file, especially for really large CSV and JSON files, doing that transformation. And the cool thing is, I didn't have to really spin up or configure anything. I just took the Dremio that I already had that's already connected to these sources, ran a quick SQL statement, and I converted that data into Iceberg tables. So this makes it really easy to take data from other sources and turn them into Iceberg tables. And again, that can be automated because, again, you can orchestrate SQL to Dremio externally, whether it's using dbt or using Airflow, using whatever tools you like to use. Okay. So I just wanted to point that out so that you could use Dremio to make a lot of ingestion patterns very easy, because basically you just connect your sources and you can run SQL between them. But now that I have that weather table, and again, I could do this with any source, I can now save this as a view. So I can actually like run some SQL on it. And if I want to save that SQL view, I can just click save as a view. So maybe here I want to save the raw data. So I'll go to marketing, run the raw folder. I'll save this as raw. Okay, and we'll call it raw weather. Oh, because it's a Nessie table. That's my bad. Whenever you're doing a Nessie table, you have to make sure you specify the branch, so that way it knows what branch to run it against. At main, at branch main. Okay, say, and let me just run that. Cool. Save as view. Raw weather. Save that in the raw layer of marketing. Okay. And then now if I go to the marketing product, there it is in raw, and this view is now accessible. And then I can go in there, do my curation, do some SQL to, to transform it, change it, then save a view of that to the silver layer, and then maybe add some business logic on top of that and save that to that production layer. And the cool thing is, for my end users, they don't have to have access to all of it. I can just sit there and specifically say, they never have access to the physical raw data sets. They only have access to the views of those data sets that I give them permission to, and which may hide PII, which may basically hide whatever data they shouldn't have access to. But you're not creating copies of the data, because these views, these green data sets, they are just logical views on the data. So there's still only one copy of the weather data as an Iceberg table. Okay, and the cool thing is, but what if, let's say I have, this particular view here, and I'm feeding a BI dashboard off of it, and I want it to be like a little bit faster. Instead of me having to like materialize every layer, what you can do is just materialize that endpoint. and do it in a way that doesn't require any work on the analyst point of view. So what I would do is I would click right here where I can edit the data set. And that's going to take me to this screen right here. And from this screen, what I do is I click on this section called reflections. Think of reflections as Dremio's feature that basically eliminates the need for materialized views and extracts. So let me just talk about like why that matters. This will be the last thing I show for today. But again, you have the blog post, so you'll be able to do and play with this more at home at no cost because you're using your local compute. So you're not paying for Dremio, you're not paying for compute costs. You can just have fun with it and play with it. And actually, again, use it for your own personal use cases. You can load Excel files. So sometimes if I'm working on something in Excel and I just want to run some SQL queries in it, I'll just load it up in the Dremio and run some SQL. But again, back to this reflections feature, problem with extracts. So BI extracts, you create like a little like physical version of the data that exists within your BI tool. That works. Problem is, what if you have 3 different teams working with 3 different BI tools on the same data? They're now doing 3 extracts across 3 different BI tools. Okay, so you're creating the same sort of physical representation of the data 3 times to accelerate those queries. Then there's cubes. Okay, so maybe your data warehouse, you're able to build OLAP cubes. So you're essentially creating another data set that pre-aggregates everything. Usually but the problem is that's just basically under another name. So the data analyst would need to know, hey, what's the name of the cube? And then make sure to swap out that name in the query. And then you'd have to rebuild that cube every once in a while. And it's just a little bit more work for the data engineer and a little bit more work for the data analyst. Now, in this case, with reflections, here you're not creating another name. Okay, so for example, if I wanted to create something like a cube, that would be an aggregate reflection. So under the hood, what Dremio is doing is that in your data lake storage, it's going to create those pre-aggregated data sets. But the analyst doesn't need to know, because when those aggregation queries come to Dremio, Dremio knows that they queried marketing.raw, and that marketing.raw has these reflections enabled. So it'll know to swap it out. So you'll get faster queries without the analyst having to adjust what they're doing. They just say, hey, guess what? These queries aren't running as fast as I'd like. You flip a switch, and they just magically suddenly everything's faster for that. Okay, so it makes it easier for the data engineer, because Dremio will be the one who actually maintains these reflections under the hood. So updates them on a period, which you can customize and whatnot. And the analyst doesn't have to change their queries. Those will just automatically get adjusted. So Dremio is doing all the work that would normally manually be done. And the cool thing is that there's aggregation reflections, which are for BI, for like BI, so all those aggregate queries. And I can actually choose, hey, which dimensions and measures I want to optimize for. But then there's also raw reflections for like raw queries. So maybe I have queries that come in that usually only use 2 columns. I can go over here to advanced and say, hey, I only want to query with these 2 columns. Okay, these are the columns that so like 90% of the time, these are the only 2 columns they care about, and they ignore the rest of the columns. So I just want a reflection that has those 2 columns sorted by name. Okay, and then I want you to partition that data by however you want to partition the data. Okay, and what that does is going to create that different alternative version of the data set. But again, the end users don't need to know. They don't need to change their queries. They don't need to query, materialize A or materialization B. They just query the same table they've always been querying, and Dremio will identify that their query matches up with a reflection that's been created, and then swap those out. Okay, and then you can create as many reflections as you want. So you see, I can click here, new reflection, and I can create multiple reflections designed to optimize for certain queries in a very point and click way. Okay. Now, again, you don't want to necessarily build too many on one data set, because again, Dremio then has to go evaluate each one against the query. But figuring out when and how to use it is becoming easier, because now Dremio has a reflections recommender. So it'll monitor the queries on your cluster and then recommend you, these are the queries that you should use. Okay. And then 2, we're working towards even more autonomous reflections, where basically Dremio will, instead of you having to like wait for it to recommend you and then you take action, you being able to actually set up Dremio to just automatically generate these when it's needed, and destroy them when they're not needed, so that we can manage those costs and manage your storage, and everything just is fast because Dremio is kind of managing the acceleration, referred to as autonomous reflections. So that's something that Dremio is currently working towards, that you'll see over the next basically more and more features working towards that in the near term. The reflection recommender sort of being the start of that. So with that, like, what have we done? We've built the Lakehouse on our laptop. Again, all these features were for free. And the cool thing about these reflections, you can use them across any source. They're not just on Iceberg tables. They're not just on, you can use them against your MySQL tables. You can use them against your Snowflake tables. You can use them against whatnot. It doesn't require you to deploy anything else. So you don't have to deploy a separate cluster. It's available in the free version of Dremio. And these are all things that are things you cannot say for many other acceleration solutions for other data lakehouse tools. So yeah, it's pretty cool. I recommend playing with it. I'll be coming out with more blogs to show you how to do that, but I will leave the QR code up for those who want to scan these QR codes for the future. And with that, I'll see if there's any other questions.
Thank you so much, Alex. I gotta say the reflections feature does sound pretty interesting. Essentially, you can like take your highest volume queries and then build reflections for them so you're getting like further optimized results from those queries, like faster.
Correct. So
Yeah.
basically, normally what you would do is that you say, oh, okay, well, there are these queries coming in a lot. You create like a materialized view. But when you create a materialized view, you're creating a whole separate structure that's under a different name. So now I have to make sure to go update that materialized view periodically if the tool I'm using doesn't do that. And then two, the underlying analyst has to make sure that they adjust their queries to hit the new structure, not the old structure. Here, we just kind of eliminate all that complexity and just say, hey, you just turn it on. The analyst queries are going to be faster as is, and the data engineer doesn't have to worry about it any further. They can get onto other tickets on their backlog.
So just thinking of this as like an analogy, it essentially sounds like you're putting like a query load balancer in place that says, send the query to the main table or the reflection, depending on what it is.
Exactly.
Yeah.
Essentially, basically part of the query planning process is that because basically since everything is within the Dremio semantic layer, Dremio is aware of the relationship between all the data sets, what the relationships are to each other. So another really cool thing is that let's say I have table A, and then I have view B, and then I have view C from view B. So like it was like A, B, C. I create a reflection on view B. Okay, that reflection will be considered not just for queries on view B, but also for queries on view C. Because Dremio knows that view C came from view B, so since it's aware of that relationship, because everything is unified on Dremio, and it's aware sort of your holistic relationship between your views and your semantic layer, you can get much more bang for your buck out of your reflections because it'll be used in other situations that make sense.
That's fascinating. Yeah.
Yeah. The more I think of sort of like the relational algebra required to pull that off, it boggles the mind, but it's a really fascinating feature.
Okay. So there are not any more questions in the chat, but I want to thank you for being here. I want to thank you for this presentation. It was really interesting. And I'm really looking forward to being able to run this on my own and get my fingers into this. So.
Awesome. Okay. Thank you very much. And I'll see you guys again soon.
Bye, everybody. Thank you for being here.